Good morning. Today's quote is: don't let the fear of losing be greater than the excitement of winning. Don't let the fear of losing be greater than the excitement of winning. Today's word is allay. To make something less strong, a lotion of sodium bicarbonate is useful to allay itching. Or we can give another example in which this word is used. Expect a breeze to allay the heat. Fourth one, exercise 5.2. The position vector of points A and B are 6a bar plus 2b bar and a bar minus 3b bar. If the point C divides AB in the ratio 3 is to 2, show that the position vector of C is 3a bar minus b bar. Now you may ask me, type of division is not given. If nothing is mentioned, we treat it as internal division. So apply section formula. C bar will be 3a bar minus 3b bar plus 2, 6a bar plus 2b bar. Every time you have to use bar notation upon 3 plus 2. So on simplification, you get C bar equal to 3a bar minus b bar. So this is position vector of C. Fifth one, prove that the line segments joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. See, original quadrilateral need not be a parallelogram or rectangle or square, any quadrilateral. Right? Now? Let ABCD be a quadrilateral. Let ABCD be a quadrilateral and PQRS, all capital letters, P comma Q comma R comma S, PQRS be the midpoints of the sides, AB comma BC comma CD and DA respectively. Let, now use small letters, A bar, B bar, C bar, D bar. Let small a bar, comma, B bar, C bar, D bar, comma, P bar, Q bar, R bar, S bar be the position vectors of the points, A, B, C, D, A, comma, B, comma, C, comma, D, now capital letters, comma, P, Q, R and S respectively. See, name of the points by capital letters, vectors strictly by small letters. Okay. Next line. By midpoint formula, Now, see on the screen. What is P bar? A bar plus B bar upon 2. What is Q bar? It is B bar plus C bar upon 2. What is R bar? C bar plus D bar upon 2. And S bar is D bar plus A bar upon 2. See, it is sufficient to prove that in a quadrilateral, one pair of opposite sides is not only parallel but congruent. It is as good as proving that quadrilateral is a parallelogram. You may also say, can we prove that diagonals bisect each other? Okay. So here, what is PQ bar? PQ bar is Q bar minus P bar. Substitute and tell me what you get. It is B bar plus C bar upon 2 minus A bar plus B bar upon 2. So that gives me half C bar minus A bar. So this is PQ bar. Now it is SR bar. Why I am considering SR bar? It is sufficient to prove that PQ bar equal to SR bar. Now SR bar is position vector of R minus position vector of S. So C bar plus D bar upon 2 minus D bar plus A bar upon 2. So this is again half C bar minus A bar. Now after this you have to write, therefore PQ bar equal to SR bar. When we say that two vectors are equal, by that we mean their magnitudes are same and directions are also the same. Therefore, I will say PQ equal to SR and PQ bar is parallel to PS bar. Therefore, quadrilateral PQRS is a parallelogram. Right now. Actually, there is one correction. PQ bar is parallel to SR bar. Now this is correct. D and E divide sides BC and CA of a triangle ABC in the ratio 2:3 each. Find the position vector of the point of intersection of AD and B and the ratio in which this point divides AD and BE. See, it is clear that we must obtain an expression involving A bar, D bar, B bar and E bar. Okay. Now, let AD and B intersect at P. Let A, B, C, D, E, P have position vectors A bar, B bar, C bar, D bar, E bar, P bar respectively. Now D and E divide segments BC and CA internally in the ratio 2:3. So apply section formula. D bar is 2C bar plus 3B bar upon 2 plus 3. So what is 5D bar? It is 2C bar plus 3B bar. First equation. Similarly, what will be E bar? 2A bar plus 3C bar upon 2 plus 3. So this gives me 5E bar equal to 2A bar plus 3C bar. Now from 1, can I say 5D bar minus 3B bar equal to 2C bar? Now note that in second equation it is 3C bar, in the first it is 2C bar. So I have multiplied throughout by 3. 3 is a scalar. So 15D bar minus 9B bar equal to 6C bar. Now from 2, 10E bar minus 4E bar equal to 6C bar. Now you should ask me, but why to do this? I have already told you that we need an expression involving uh, B bar, E bar, A bar and D bar. That is, we do not want C bar, and to eliminate C bar we have done this. Equating both values of C bar, we get this. Rearrange the terms. So 15D bar plus 4A bar equal to 10E bar plus 9B bar. Divide by 19, write 19 on LHS as 15 plus 4 and on RHS 10 plus 9. Why? So that I can say that left hand side is the position vector of the point which divides segment AD in the ratio 15:4, and the same point divides or RHS is the position vector of the point which divides segment BE internally in the ratio 10:9. But P is the point of intersection of AD and B. So P divides AD internally in the ratio 15:4 and BE in the ratio 10:9. That's it. Now, question 7. Prove that a quadrilateral is a parallelogram if and only if its diagonals bisect each other. Right? Now, if and only if means we have to prove the converse also. That is, if diagonals bisect each other, then it's a parallelogram. This also we have to prove. Right down. Let A bar, B bar, C bar, D bar. Let A bar, B bar, C bar, D bar be the position vectors. Be the position vectors of the vertices. Position vectors of the vertices A, B, C and D respectively. Now capital letters A, B, C, D respectively of parallelogram ABCD, of parallelogram ABCD. Therefore, AB equal to DC and side AB parallel to side DC. Side AB parallel to side DC. Therefore, AB bar, see presentation is important. AB bar equal to DC bar. Now tell me what is AB bar? B bar minus A bar. And what is DC bar? C bar minus D bar. Rearrange the terms. So B bar plus D bar is A bar plus C bar. It's not at all difficult. Now I write this as A bar plus C bar upon 2 is B bar plus D bar upon 2 equal to M bar, say. Okay. After that, write down. Therefore, the midpoints of the diagonals AC and BD are the same. Therefore, the midpoints of the diagonals AC and BD are the same. Why? Because M bar is position vector of the point M, which happens to be the midpoint of both the diagonals. Simple. Next line. This shows that diagonals bisect each other. I hope you are getting this. I repeat this part. If you read the sum carefully, you are asked to prove that a quadrilateral is a parallelogram if and only if its diagonals bisect each other. So in the first part, we treat quadrilateral as parallelogram and then we have proved that diagonals bisect each other. Now we will write in the second part that we are given that diagonals bisect each other. So in that case, it has to be a parallelogram. Okay. Now write down second part. Second part. Conversely, suppose that diagonals AC and BD, conversely, suppose that diagonals AC and BD of quadrilateral ABCD. Now don't call it as parallelogram. We have to prove it. I repeat this statement. Conversely, suppose that the diagonals AC and BD of quadrilateral ABCD bisect each other. Quadrilateral ABCD bisect each other. That is, they have the same midpoint. That is, they have the same midpoint. Therefore, the position vectors of these midpoints are equal. Therefore, position vectors of these midpoints are equal. So A bar plus C bar upon 2, B bar plus D bar upon 2. So A bar plus C bar is B bar plus D bar. So B bar minus A bar is C bar minus D bar. Therefore, AB bar equal to DC bar. That is AB equal to DC. AB means mod of AB bar. AB equal to DC and side AB is parallel to side DC. And this happens only if quadrilateral is a parallelogram. Therefore, quadrilateral ABCD is a parallelogram. Question 8. Again, this is an important one. Prove that the median of a trapezium is parallel to the parallel sides of the trapezium and its length is half of the sum of the lengths of parallel sides. Okay. I hope you have drawn the rough sketch. Write down. Let A bar, B bar, C bar, D bar, small. Let A bar, B bar, C bar, D bar be the position vectors of the vertices. Let A bar, B bar, C bar, D bar be the position vectors of the vertices. Now capital A, comma B, comma C and D, A, B, C, D respectively of trapezium ABCD with side AD parallel to side BC. With side AD parallel to side BC. Therefore, next line, therefore, AD bar and BC bar are parallel. Therefore, AD bar and BC bar are parallel inside the bracket collinear bracket complete vectors. Therefore, AD bar and BC bar are parallel inside the bracket collinear bracket complete vectors. Right on. Therefore, AD bar is what? It is KBC bar. Why? Because if two vectors are collinear, one can be expressed as non-zero scalar multiple of other. Therefore, AD bar plus BC bar is KBC bar, because I have to replace AD bar by KBC bar, plus BC bar, that is K plus 1 BC bar. Okay, right now. This is say number 1. Next line. Let m bar and n bar, small m, small n. When I say bar, you have to use small letter. Let m bar and n bar be the position vectors of midpoints. Let m bar n bar be the position vectors of the midpoints m and n of non-parallel sides, because you should know the meaning of median of trapezium. Non-parallel sides AB and DC respectively. AB and DC respectively. Then segment MN is the median of trapezium. Segment MN is the median of trapezium. Segment MN is the median of the trapezium. By midpoint formula, write down. By midpoint formula, what is m bar? A bar plus B bar upon 2. What is n bar? It is D bar plus C bar upon 2. Now mn bar is position vector of n minus position vector of m. Basic definitions. Substitute the values. See what you get. Mn bar. So this is half. See what I'm writing. I'm rearranging the terms. D bar will go with A bar. Okay. And C bar with B bar. So this is half AD bar plus BC bar. So finally I can say this is half. Now in 1, see what we have written. We have written this as K plus 1 BC bar. I'll mention the reason here. From 1. Okay. Now we have expressed Mn bar as what? Scalar multiple of BC bar. This means Mn bar is parallel to BC bar. We have to prove this only. And of course, second part is also there. Therefore, I can say Mn bar is parallel to BC bar. But BC bar is parallel to AD bar. As BC bar is parallel to AD bar. It's a trapezium. Mn bar is parallel to AD bar also. So what is the conclusion? That median is parallel to parallel sides. Now this is actually the first part. Now you will notice that AD bar and BC bar are collinear and in the same direction. AD bar, BC bar are collinear in same direction. So what is mod of AD bar plus BC bar? It is simply AD plus BC. Okay. Now I can say we have proved this, that Mn bar equal to AD bar plus BC bar upon 2 gives Mn equal to what? It gives Mn equal to AD plus BC divided by 2. That's it. Sum number 9. If two of the vertices of a triangle are A and B, 3, 1, 4, minus 4, 5, minus 3, and the centroid of the triangle is at G, minus 1, 2, 1, then find the coordinates of the third vertex C of the triangle. Some say that as this is sum from the topic vectors, it is better that you obtain position vector of all the points. But I think coordinates are asked, so one can directly go for x equal to x1 plus x2 plus x3 upon 3 also. Okay, but here we'll use vector method. Better. Let a bar, b bar, c bar and g bar. Let a bar, b bar, c bar and g bar be the position vectors of A, B, C and G respectively. A, B, C and G respectively. Therefore, A bar equal to, what is A bar? 3i plus j plus 4k. B bar equal to minus 4i plus 5j minus 3k. And G bar equal to minus I plus 2j plus k. The position vector of the centroid capital G is given by, the position vector of centroid capital G is given by, yes, what is G bar? A bar plus B bar plus C bar upon 3. Now RM is to obtain C bar. So 3G bar is A bar plus B bar plus C bar. So what is C bar? It is 3G bar minus A bar minus B bar. Now substitute and tell me what is C bar. Don't just copy. Find on your own. 3G bar minus A bar minus B bar. Yes, you should get minus 2I cap plus OJ cap, that is 0 J cap plus 2K cap. So this is C bar. So from this, vertex C is what? What are the coordinates? Don't write minus 2, 2. minus 2, y coordinate equal to 0 and z coordinate is 2. So C is what? Minus 2, 0, 2. Listen to me, but please do write the solution after the lecture. In triangle OAB, E is the midpoint of OB and D is the midpoint, not midpoint, I'm sorry. In triangle OAB, E is the midpoint of OB and D is the point on AB such that AD is to DB equal to 2 is to 1. If OD and AE intersect at P, then determine the ratio OP is to PD using vector method. Now, as this point is given as O, why not to take this as origin? So that position vector of O with respect to origin will be 0 bar. Solution. Let A, B, D, E, P have position vectors A bar, B bar, D bar, E bar and P bar respectively with respect to O. Now AD is to DB is 2 is to 1. So by section formula, what is D bar? 2B bar plus A bar upon 2 plus 1. So 3D bar is 2B bar plus A bar. Now E is midpoint of OB bar. So what is E bar? It is half OB bar, that is B bar by 2. So B bar equal to 2E bar. Now from 1, can I say 3D bar equal to, see, it is 2 into 2E bar plus A bar. I hope you are getting this. I have replaced B bar by what? In equation 1, I have replaced B bar by what? Because I don't want B bar in the expression. I replaced it by 2E bar. So 3D bar comes out to be 4E bar plus A bar. Now next step is interesting. Can I write the same as 3D bar plus 2, there should not be dot here, 2O bar, that is 20 bar rather, upon 3 plus 2 equal to 4E bar plus A bar upon 4 plus 1. Why to divide by 5? Because we have to bring this in which form? MB bar plus NA bar upon M plus N. So we have written the same in required form. Now what is LHS? LHS is the position vector of the point which divides OD internally in the ratio 3 is to 2. Don't say DO, say OD, because D bar is followed by 0 bar. Now what is RHS? It is position vector of the point which divides AE internally in the ratio 4 is to 1. Actually, this is not asked. Anyway, we have to write this because this clearly indicates that these two, OD and AE, intersect at P. So what is asked? We are asked to find OP is to PD. So it is 3 is to 2. Eleventh, if the centroid of a tetrahedron OABC is 1, 2, minus 1, where A is A2, 3, B is 1, B2, C is 2, 1, C, find the distance of PABC from the origin. Basically, you should know the centroid formula. Suppose tetrahedron is ABCD, then centroid has position vector A bar plus B bar plus C bar plus D bar upon 4. Okay, right on. Now we will write solution in short. I hope you have drawn the diagram. By formula of centroid of a tetrahedron, I am writing it directly. By formula of centroid of a tetrahedron, what is G bar? 0 bar, which is position vector of O, plus A bar, plus B bar, plus C bar upon 4. So 4G bar is A bar plus B bar plus C bar. Actually, in the beginning, you had to say that point A is A23. So its position vector is AI cap plus 2J cap plus 3K cap and so on. Here I have written directly. So 4. Now substitute. What is G bar? Tell me. It is I plus 2J minus K. Start writing. I plus 2J minus K. What is A bar? A bar is AI cap. See, coordinates are given. Plus 2J cap plus 3K cap plus I cap plus BJ cap plus 2K cap. And what is C bar? 2I cap plus J cap plus CK cap. Okay. Now three unknowns, three equations. So 4I plus 8J minus 4K equal to, take I cap common. See what you get. I think you should get A plus 1 plus 2. Okay, I'll write that step. A plus 1 plus 2I. Okay, take J cap common. So it is 2 plus B plus 1 J. Now take K cap common. So that gives me what? 3 plus 2 plus C. Is it? After this, you may say by equality of vectors or equating rectangular components. Same thing. By equality of vectors, because we have seen that this representation is unique. By equality of vectors, A plus 1 plus 2 is 4. Therefore, A is 1. Then 2 plus B plus 1 is 8. So B equal to 5. 8 minus 3. And 3 plus 2 plus C equal to minus 4. So what is C? Minus 9. Now they say that these are the coordinates. ABC are the coordinates of point P. So PABC is what? 1, 5, minus 9. What is asked? Distance of P from origin. So find out. Therefore, distance of P from origin is root of 1 square is 1, 5 square is 25, 9 square is 81. So it is what? Root 107. Is it? You may say root 107 unit. That's it. Sum number 12. Find the centroid of tetrahedron with vertices K 5 minus 70, L 153, M 4 minus 63, N 6 minus 42. Do not take K bar as position vector of capital K, because K cap or K bar is taken as unit vector along positive direction of Z axis. Okay. So take it as P bar. See, you have to write detailed solution by writing let P bar, L bar, M bar, N bar be the position vectors of the points K, L, M, N respectively with respect to some origin O and so on. And then centroid of tetrahedron has position vector G bar equal to. I have written this directly. Substitute. Tell me what you get. On addition, you should get 16i. Don't write this directly. 16i minus 12j plus 8k divided by 4. So this is nothing but 4i minus 3j plus 2k. Therefore, centroid of tetrahedron is G 4 minus 3 2. Yes, this definitely lies inside this tetrahedron. So that's it for today.